Hello everyone, welcome back to my YouTube channel. My name is Arnav Jain and I'm currently working as an SDE2 at Amazon. In this video, we are going to talk about the Liskov substitution principle. So far on this channel, we have already covered what design patterns are, along with solid principles like the single responsibility principle and the open-closed principle. In this video, we will focus on the Liskov substitution principle, also known as LSP or L in solid. So what does the Liskov substitution principle actually mean? In simple terms, it means that objects of a subclass should be replaceable with objects of the parent class without breaking the application. In other words, if a piece of code works correctly with a parent class object, it should continue to work correctly even when we pass an object of its subclass without changing the client code or introducing unexpected behavior. So now let's take an example and understand this principle. I'll start by creating a class called bird. Inside this bird class, I'll add a function called fly. Now, whenever we create an object of bird and call bird.fly, this output should be printed. Let me try that quickly. So here I've created an object of bird and I'm calling bird.fly. Let's run this. Yep, it runs successfully and we get the expected output. Now let's move one step ahead and create a subclass of bird. I'll create a class called eagle which extends bird. So eagle is basically a subclass of bird. Inside eagle, I'll override the fly method. Earlier the log was bird can fly. Now I'll change it to eagle can fly. According to the Liskov substitution principle, I should be able to replace the parent class object with the subclass object without breaking anything. So instead of creating a bird object, I'll now create an eagle object but still reference it using the bird type. Let me run this again. Yep, it works. I'm getting the output eagle can fly. Even though the message is different, the code is still working correctly. The client code did not break and I didn't have to change anything there. That's exactly what Liskov substitution principle is about. You should be able to replace a parent class object with a subclass object and the behavior should still be correct. Now this is a very small and simple example. In real projects, you'll have many more classes and much more complex logic. We'll look at those scenarios in further videos. But for now, this example should give you a basic understanding of the principle. Now, there are a few rules that you should follow when you are creating a subclass so that it stays aligned with the Liskov substitution principle. Let's go through them one by one. The first rule is about parameter types. So what this rule says is that the method arguments in a subclass must either match the parent class parameter type or be more abstract than it. In other words, a subclass should not expect a more specific input than what the parent class expects. Because if the client code is written assuming the parent class contract and the subclass suddenly requires a stricter parameter, that substitution will break. Let's take an example to understand this. Extending the bird example again to understand this rule, let's create a bird class first. Inside the bird class, I'll add a function called eat, and this function will take food as a parameter. Food here is a separate class, so we'll be passing a food object to the eat method, and it will return something like bird is eating. Now let's try this. I create an object of bird, and I call bird.eat, passing an object of food. Ideally, this should work. Let me run this. Yep, this is working as expected. Now let's create a subclass of bird. I'll create a class called sparrow, just like we did earlier. Inside sparrow, I'll again add an eat method, but this time I'll make it take seeds as a parameter. Now seeds is a subclass of food, so seeds is a more specific type of food. Inside this method, I return something like sparrow is eating seeds. Now according to the Liskov substitution principle, I should be able to replace the parent class object with the child class object. So instead of creating a new bird, I replace it with a new sparrow and I still call bird.eat. Let's run it. it fails. And the reason it fails is because this method does not correctly override the method present in the bird class. The eat method in Sparrow is expecting a more specific parameter type than the one defined in bird. In the parent class, the method accepts food, but in the subclass, it accepts seeds. That breaks the contract. So to fix this, the eat method in Sparrow must also accept food as a parameter. Once I change the parameter type back to food, the method correctly overrides the parent method and the code works again. Now if I pass a seeds object here, that will also work because seeds is a subtype of food. So what this rule is telling us is very simple. A subclass should not narrow the parameter type of a method that it overrides. The parameter type in the subclass must be the same as or more general than the one defined in the parent class. That way, the subclass can always safely replace the parent class without breaking the client code. Similar to the previous example, there are other cases where this rule applies as well. For example, let's say we have a feed function that takes a cat as a parameter. Now in the subclass, if instead of cat we use animal as the parameter type, that is perfectly fine. Because cat is an animal and animal is more abstract than cat. So the subclass is not restricting the input, it is actually allowing more flexibility. Now let's look at a bad example. Suppose the parent class has a feed method that takes cat as a parameter, but in the subclass, the feed method takes Bengal cat as the parameter. Now Bengal cat is a subtype of cat, which means it is more specific. This is a problem because the subclass is now expecting a stricter input than what the parent class promised. If the client code passes a regular cat, the subclass will not be able to handle it. So this breaks the Liskov substitution principle. That's why, when it comes to method parameters, a subclass should never use a more specific subtype than the one defined in the parent class. It should either use the same type or a more abstract one. So yeah, let's move forward with rule number 2. Rule 2 talks about return types. This rule says that the return type of a method in a subclass must match or be a subtype of the return type defined in the parent class. Now this is completely opposite to what we learned in rule 1. In rule 1, for parameters, we said the subclass should accept more generic or more abstract types. But for return types, the subclass must return a more specific type. Let's understand this with an example. We'll extend the same bird example again. First, I create a bird class. Inside the bird class, I define a method called getFood. This getFood method returns a food type. Food here is a separate class, and for now, I'm returning a new food object. Now I create an object of bird and call bird.getFood. When I run this code, it executes successfully. Now let's extend this further. I create a Sparrow class which extends the bird class. Inside Sparrow, I override the getFood method. This time, the getFood method returns a seeds object. Seeds is a subtype of food. According to the Liskov substitution principle, a subclass object should be able to replace a parent class object without breaking the code. So instead of creating a bird object, I replace it with a sparrow object and still call getFood. When I run the code again, it still executes successfully. This works because the parent class promises to return food and the subclass returns seeds, which is a subtype of food. Now let's look at a bad example. Suppose in the sparrow class, instead of returning seeds, I return object. Object is more generic than food. Now if I try to run this code, it fails. Because the parent class promised to return food, but the subclass is returning a more generic type. This breaks rule 2 and violates the Liskov substitution principle. So remember this. For return types, the subclass must return the same type or a subtype of the return type defined in the parent class. Now let's take two more examples to understand rule 2 more clearly. Suppose in the parent class, I have a function called byCat. This byCat function returns a cat type. Now in the subclass, I override the byCat function, but this time it returns a Bengal cat. This follows rule 2. Why? Because Bengal cat is a subtype of cat. The parent class promised to return a cat, and the subclass is returning a more specific type. So this does not break the contract. Now let's look at a bad example that does not follow this rule. Again, in the parent class, we have a byCat function that returns a cat. But in the subclass, the bycat function returns an animal. Animal is not a subtype of cat. In fact, animal is a superclass of cat. This violates rule 2. Because the parent class promised to return a cat, but the subclass is returning a more generic type. So this breaks the Liskov substitution principle and the code will fail. Now let's move forward and understand rule number 3. Rule 3 says that a method in a subclass should not throw an exception that the base class method is not expected to throw. Why is this important? Because client code is usually written with a try-catch block based on the exceptions declared by the base class. If a subclass suddenly throws a new or unexpected exception, it slips past the client's defense and crashes the application. Let's understand this with an example. We'll take the bird example again. First, I create a bird class. Inside the bird class, I define a method called fly. When this method is called, it simply prints bird is flying. Now in the main class, I create a bird object and call bird.fly. When I run this code, it executes successfully. Now let's create another class called ostrich. Ostrich is a bird, but it cannot fly. So in the ostrich class, I override the fly method and throw an exception saying cannot fly. Now according to the Liskov substitution principle, I should be able to replace the bird object with an ostrich object. So I replace new bird with new ostrich and run the code again. The code fails. Why does it fail? Because the bird class never promised that fly would throw an exception. But the ostrich class is now throwing one. This is a surprise for the client code. The client was not prepared to handle this exception, so the application crashes. Now, one possible workaround is to force the base class to declare the exception as well and wrap the fly call inside a try-catch block. But this is not a good design because the base class bird was never intended to throw an exception while flying. We are weakening the base class contract just because one subclass behaves differently. The correct solution is to separate the behavior. Instead of assuming that all birds can fly, we remove the fly method from the bird class entirely. Now we create a separate interface called flying bird. This interface defines the fly method. Now let's look at sparrow. Sparrow is a bird and it can fly. So sparrow extends bird and implements flying bird. Now let's look at ostrich. Ostrich is also a bird, but it cannot fly. So ostrich extends bird, but does not implement flying bird. Now everything is clean. If I replace a bird object with an ostrich object, nothing breaks, because bird does not promise any flying behavior. Now if I try to call bird.fly, I get an exception saying the fly method does not exist. And this makes sense because the bird class itself does not have a fly method anymore. And ostrich also does not implement fly. Now suppose I replace ostrich with sparrow. Ideally this bird.fly should work, right? But when I execute it, I still get the same exception. Why does this happen? Because even though the object is actually a sparrow, the reference type is still bird. And bird does not have a fly method. So the compiler does not allow this method call. Now if I change the reference type from bird to sparrow and then call sparrow.fly, it works successfully. So yeah, the key takeaway here is this. Never throw an exception in a subclass that is not thrown by the base class, because the client code is written based on the base class contract. If a subclass throws a new unexpected exception, it breaks that contract and can crash the application. And even if a method behaves differently for different subclasses, do not force that behavior into the base class. Instead, separate things out. Create a separate interface, move that behavior there, and your code will be much cleaner and will correctly follow the Liskov substitution principle. Let's move to rule number 4. Rule 4 says that a subclass should not change the values of private fields of the parent class. The parent class depends on the internal consistency of its private state to function correctly. If a subclass directly modifies those private fields, it breaks those assumptions and violates the Liskov substitution principle. In some languages like Java or Python, it may be possible to access or modify private members either directly or indirectly, but you should avoid doing that. A subclass should respect the internal state and invariance of its parent class. So with this, we have now covered the Liskov substitution principle. Till now in this series, we have covered the single responsibility principle, the open-closed principle, and the Liskov substitution principle. In the upcoming videos, we'll move forward with the interface segregation principle and the dependency inversion principle. Once we complete all the solid principles, we'll then switch to design patterns and go into them in much more depth. If you found this video helpful, please like and subscribe to the channel. Your support really helps this channel grow. Stay connected, keep learning, and I'll see you in the next video.